All right, number 8, ladies and gentlemen, we got the equilibrium constant Kp for this reaction is 4.4 at 2000 Kelvin. We are going to calculate delta G. All right. So for A, delta G equals negative RT ln So delta G standard equals negative 8.3145 joules per mole Kelvin, 2000 Kelvin, times the natural log of 4.40. So that means delta G standard is negative 8.3145 times 2000 times the natural log of 4.40. I get negative 24637.601911, which and that's joules per mole. We have 3 sig figs. Well, it's kind of ambiguous, isn't it? 2000 Kelvin. All right, I'm going to assume 3 sig figs for temperature. All right, I'm assuming that. The book was kind of vague about that, wasn't it? I don't appreciate that. All right, so for 3 sig figs, it's negative 24600 joules per mole, or negative 24.6 kilojoules per mole. So there's A, done. B, now looks like the same. We're calculating delta G standard. Now we're calculating delta G. Well, I did that backwards so far. We're calculating delta G standard there, and now we're calculating delta G. All right, different partial pressures. So let's see, H2, CO. All right, so what is Q for the reaction? Q would be equal to what? We're doing pressures, so this is QP. Pressure of water times the pressure of carbon monoxide all over the pressure of H2 and the pressure of CO2. So there's our reaction quotient expression. All right, and so our formula, delta G equals delta G standard plus RTLNQ. All right, so delta G equals, I'm going to, right, because R is R, so I'm going to use negative 24600 joules per mole plus 8.3145 joules per mole K (2000 K) natural log of, all right, H2O. H2O is this one, 0.66 atmospheres. The units are just going to cancel. We just ignore the units. CO, 1.2. Next is H2, which is 0.25. And CO2 is 0.78. All right. Let's see what we get for delta G. Negative 24600 plus 8.3145 times 2000 times the natural log of all of this, 0.66 times 1.2 divided by 0.25 divided by 0.78. I got, let's see, did I do my numbers right? Negative 2,400, 8,345,000, 0.66, 1.2, 0.25, 0.78. I got negative 1293, right? Which is the same thing, joules per mole, which is negative 1.29 kilojoules per mole. All right, that's what I got. All right, let's see here. If you would have broken it up, let's just say we'd have broken it up, all right? In the reaction quotient, we get 0.66 times 1.2 divided by 0.25 divided by 0.78. I'd have got 4.062 here. All right, and then the natural log of 4.062 is what? 1.402. All right, times your 200 Kelvin. 1.402 times your 2,000 Kelvin times 8.3145 is 2331. So I'd have had, for the whole term, 23310 joules per mole. So negative 24600 plus 23310. Excuse me. Yeah, I'm still getting negative 1. Yep, we're good. All right, very good. So whether you broke it up or you did it all at once, I'm getting the same answer. I hope that makes sense, guys. And we'll see you in the next one.